Coralogix is a company that has been around for a number of years, has become real area experts on logging in the modern cloud era, as well as CI/CD. And they have also learned a ton over the time that they've been around, and they're here to share their specific insights with you on the call. So with that, I will turn it over to Ariel Assaraf. He is the CEO and co-founder of CoreLogics, and I'll kick it over to him to get things started. And again, thank you all so much for joining. Ariel, take it away.
Thank you very much, Spencer. Hi, everyone. I'm Ariel, CEO of Coralogix. After this great introduction, I don't have much to add. I'll just say a couple words about us. Coralogix is a machine learning powered log analytics platform. We built it to fit companies for the CI/CD area. That means that we help companies benchmark versions, integrate with their pipelines, and provide insights in the context of versions. During the past 5 years, ever since we founded Coralogix, we've been serving over 1,000 companies worldwide from different industries, different sizes. And we had the opportunity to do workshops with many of those companies and really learn about their tech stack, about their needs, about their problems, and look at their data together and see how to improve. So this session is a session that we've been running for a while now. To really go back to the basics of logging. Why do we need logs? How to use them properly? And at the end, how do we turn logs into a monitoring tool? And how do we turn logs into a powerful way to improve your CI/CD, both the process itself and how it affects your production? So I want to start with the agenda. First of all, we'll talk a little about the formats of data. Unstructured versus JSON, why we prefer JSON, the advantage of it, and how do we transform to JSON if we're not there yet. Log severity definition, a problem that we see with many companies not properly defining their severities and then having to fix it using the Coralogix parsing engine. So how do we standardize severity across an organization so that our logs are actually speaking the right volume. Logging best practices. A few ideas of things that you want to log, how you want to log them, why you want to do so, and how does that improve your production, improves your monitoring. Alerts. So there are three topics in alerts that I want to cover. Why do we need them? Because a lot of companies use logs as a postmortem tool. They use APM or matrix data for their monitoring, and they only use logs to dig into data. This is a very classic use case. Although we've seen in many companies that logs being the best source of truth that you actually have and being the most real-time component that you have in comparison to matrix and APM that are always lagging. If you use them properly, you can really improve your monitoring stack, get better alerts in real time. So we want to learn how to properly define them. And then how do we push alerts? Do we push them to Slack? Do we push them to PagerDuty? Which alerts do we want to push in, and which alerts we prefer just to display? How do we enhance our CI/CD pipeline using logs? So a lot of companies are focused now in shifting from the old school type of deployment, the waterfall deployment, to a more agile process where you deploy more versions every day. That's great. That brings you faster to market. That makes you a faster responder to issues coming up and new features that you need to deploy. But it comes with a lot of risks, both in terms of security and in terms of quality. So there are two things that I want to touch here. First one is, how do I do proper deployments, fast deployments, well covered with tests, and how do we use logs to ensure that? And second, how do we benchmark the versions that we deploy to production using our logs? So there are a lot of things that you can learn from your log data after you deploy a version if you just tag that properly and you have the right tool set to do so. And that really improves your delivery speed without compromising the quality of your versions. The power of logs and custom matrix generation. This is it's a new topic that we're starting to cover in Coralogix, and we've seen great results. There are some serious limitations to time series DBs in everything that's related to custom matrix, and logs bring a very good answer to that I probably want to cover. Then we'll briefly talk about Coralogix and our new approach towards logging. How does Coralogix help companies really accelerate their both production recovery time, and also how do we accelerate CI/CD processes using proper logging in the tool set that Coralogix offers. And at the end, a bonus question, which I'm probably sure if you guys are here, like I see a few tens of people, you're probably messing around with logs for quite a while. I'm not sure any one of you actually thought of why are logs called logs. So this is an interesting question, and I'll answer if you guys stick around. So first topic is, why do we like JSON? And I think, when Splunk started about 15, 16 years ago, most of the data was unstructured. A lot of companies work with unstructured logging. There was this myth about logs needing to be very short, because otherwise it'll choke your network bandwidth. It'll create performance issues. As we modernized software, as cloud computing and microservices emerged, we want to have rich logs. We want to have a lot of metadata, a lot of context to each logs. So JSONs are JSON format basically won that war, and this is because it's very easy to filter and group by. It's very easy to add context to data. It's very easy to visualize, specifically with tools like Kibana and Grafana that are well supportive of JSON format. It's easily read. It's not that like those long messages where you have to browse through the log and expand and actually scroll through lines of logs. It's actually very short messages, and you only read the metadata that you need. That way you can build your custom views based on what you care about. So you can make like a one size fits all, create a good JSON log, and each one of your team can actually customize the grid and the views that he's using. That way achieving maximum productivity. And if you're not using JSON format yet, it's very easy to transform your logs to JSON. There are a lot of libraries for Winston, for Java, for Python that will help you turn your logs into a JSON format. And you can also use grok filters and Logstash or FluentD or regular expressions to parse your data and turn your legacy logs into JSON format. And then basically from now on, starting to write JSON format logs. So you only need to do that work once and then implement that a new library or a new way of working inside your organization. It goes a long way, and we definitely see with any company that companies that are using structured data are getting faster results. They are investigating issues faster. They're utilizing our system and also external APIs and Kibana and Grafana that we offer much better. And it definitely reflects that modern companies are currently like using JSON as the only option for logging. Here's a quick example of a search of a log. So if I have 2 lines of unstructured data, and I'm now trying to do grep on the number 29, I'd get these 2 lines because it appears here, but it also appears here. And that means that I'm basically unable to search that data properly, and I need to write regular expressions and other stuff that are more complex. And now if I need to add a few more conditions to that, it means that in any search, I'm going to get some irrelevant lines of log. And JSON log that allows me to tag exactly the type of data that I'm looking for allows me to do smarter, faster searches and only get relevant data. So here, if I just queried age 29, I just get this first line without the second one. A little about log severity definition. Like I mentioned at the beginning, a big pain point for a lot of companies because people are different in their nature, and it's very hard to standardize. Because if I'm a person that is generally a little more stressed, I'd probably put a lot of logs under errors that are more chill people would probably put under warning, or even I can put it under fatal. And that creates a big problem for SRE teams, for on-call teams, because when I'm investigating and I see a fatal error, I'm expecting it to be a very, very important log that I must read during that investigation. And if people misuse that, then it damages my filtering of data. It damages my ability to triage and really get to the logs that I want to look at. And it damages my judgment of what's important and what should I escalate. So a few general guidelines on how I want to do this. Debug and verbose logs. You usually want to describe background processes, things that happen and they're just happening in the background. They're not related to anything that is currently happening, like a debug message that says the number of messages in the queue is something. This doesn't mean that there's an action that was performed. It doesn't mean that there was an error or anything, but it means that something is happening in the background, and I'll probably use it if something goes wrong. And we'll get to that once we move forward with the different severities. Info logs will probably be best to use to describe actions or complete a transaction. So if I've transferred money, I'll get money transaction completed successfully. If a user signed up, I'd see user signed up. And that goes with the debug log. So I see the number of messages in the queue, and then I see 1,000 user created, and then I'll see number of messages is 2,400. So these go together, and I don't really care about them unless something goes wrong. Warning would be something around unexpected behaviors that were well treated in my code. So I'm not talking about handle exceptions, but I'm talking about things that are not 100% right, but they don't do any harm to my users or my system. So for instance, received a legal character for a user named James because he used a $ as an S, ignoring character. So in this case, I see something strange that's happened, but it doesn't affect anything. I just ignore that character. And if I get a bunch of these, I can use that to say, okay, let's limit only to alphanumeric characters in my user creation form. So this is helpful to understand things that are abnormal and happening in our software, but it doesn't need to reflect actual issues. Errors are failed transactions. Errors are the opposite of infos. So money transaction completed successfully, the error would be failed to transfer money, or in this case, failed to execute query for a user ID. This is an important error. Someone had failed to do something with my system, but it doesn't mean that I need to wake anyone up unless it happens at huge numbers. It doesn't mean that there's a crisis. It just means that a process, a transaction failed. And critical and fatal logs should be very carefully used. They're only used to really describe critical issues that should be alerted on. And whenever I have a critical or fatal log, something really serious is happening. For instance, no connection to DB, failed to register user. That's a fatal error, and someone needs to wake up right now and have a look at it. So by standardizing these, by having these as guidelines to developers, or using tools like rock filters or regular expressions, or that, for instance, in Coralogix, our rule engine, to create standardization by converting severities based on your rules and your understanding, you create a common language inside your organization. And whenever someone will see a fatal error, he knows that something very bad happened. You can define easier alerts. It's easier to speak in common language and escalate things if needed. So that's about log severities. Some logging best practices. So these are some experiences that we've gathered throughout the past few years about proper logging that brings you better results. So one thing you definitely want to log is communication between components. A lot of times people focus on debugging inside their services, inside their components, but many errors happen in the communication between microservices, between instances. So whenever, for instance, my ingest service send a message to my Elasticsearch service, I want to have a log saying a bulk of this amount of messages was sent to Elasticsearch at this IP and this cluster name. And then I want Elasticsearch, once I digest these logs, I want to have a different log saying this amount of logs were digested successfully coming from this ingest service. That way, when I have an issue, it's very easy for me now, not just to look for failures on both ends, but actually to take these two logs and say, okay, this service says it sent this amount of messages. This service said it digested fewer messages. Now let's dive into errors and we know who to blame. So that really helps you in pinpointing issues. And this is just a very simple example. You can think of multiple more examples. Log communication with external APIs, that's critical. A lot of companies today rely on external APIs for machine learning, for payments, or even for simple things like email delivery. So for instance, in Coralogix, we send alerts to Slack, we send alerts to PagerDuty, we send alerts to email. So we use SendGrid to deliver emails. What we do is we document and log every communication, every message that we send to SendGrid with all the relevant parameters that were sent. So the entire JSON that was sent to SendGrid. That way, if for instance a user complains that he did not get a very important email alert, it's very easy to me now to go back to my logs and see what message, if I send to SendGrid, and understand that I have an issue because I did not send that message properly, or if I send it with illegal characters or with illegal format. And then if the message was sent properly, I can go to SendGrid and dig in there, or maybe open a ticket to SendGrid and say, guys, this is the message I sent. I just sent it again now via Postman, whatever, and it did receive. So what happened there? And try to get their audit. So if you log communication with external APIs, that really helps you, because this is like a black hole that someone can, you can identify an issue, but then you don't really know where things got lost. Another very important best practice is to add valuable metadata to your logs. So like I mentioned at the beginning, each and every engineer department team has their own view and own things that they want to look at when they are debugging. When you add the right metadata, like the cluster name, the service, maybe user ID, maybe you even have a trace ID, that really helps people from different departments understand what happened whenever they read your log. So add metadata, don't be afraid. Like I said, you know, these days people write these huge logs, rich formatted logs with a lot of metadata, a lot of context. We don't need to keep logs very short anymore. So add anything that you need in there, you know, obviously in something that is reasonable, and it'll go a long way whenever you have an issue and you want to understand and also further analyze and visualize the data. Remember, you're not the only one reading these logs. We're seeing a lot of times in customers that there are errors that are basically unreadable, huge prints, or people that write things that only they understand, like bad error, contact someone. This is something that I definitely seen in past. So you want to write logs, and sometimes as your company scale, you tend to forget that now your team might be 5 or 10 people or 20 people that know that code and that service. But hopefully the team grows, and now you need to support NOC teams, and you need to support SRE teams that are sometimes hired later down the road. And these guys need logs that they can read and really understand. So that goes together with valuable metadata, and also the actual string needs to be something that people can understand and relate to. And the last one is something that we've seen with a few companies, and they do that really well, combining textual and matrix fields. So for instance, if you print an error, maybe you want to add a few fields there and give a snapshot of the CPU memory thread count during that exact time frame. It doesn't replace your matrix tools or your Grafana or Prometheus, but whoever reads that error now has a very quick snapshot of things and leads that he needs to look into. So that's also something that we've seen and work really well in terms of shortening the time it takes to solve production problems. A little about alerts. So I mentioned the reason that I think that alerts and on logging and monitoring using logs is very important. Logs are the best source of truth you have. They're generated as your code runs, and they happen to be a lot faster to notify on important issues in many cases than matrix. Matrix are many times lagging. Issues start in your code, they generate errors, they generate logs, and only then you'd see rising trends of errors or bad performance on your servers or an increase in latency or something like that. Logs are actually the first ones to alert. So if you know how to write proper logs with the proper severity, you can define good alerts and be notified way before your matrix go wild. And the way to define proper alerts is to define very detailed alerts. One thing that I see with many companies, and is really, I think, wrong, is defining general alerts. Like, let me know if there are over 1,000 alerts, over 1,000 errors in the past hour. Or let me know if there's a critical log, whichever log it is. These type of alerts are very confusing. You're just moving your log feed to your email or to Slack or to Pager in worst case. What you want to do is you want to define really pinpointed alerts that say something like an error happened to a user trying to purchase on the website, and then your log will be severity error and then message purchase failed and environment production and geography US. Whoever gets that alert, and we'll talk about how you create the right structure, now knows exactly what happened, where it happened. He can update customer success or customer support in case anyone complains. Now they have a straight answer to give. And he's essentially identifying and solving the problem faster, and also letting other departments know what's happening way faster and give an ETA way faster. So that it goes a real long way to just break down those alerts to 5, 6, 10 proper alerts instead of those general alerts that only tell you, hey, you have a bunch of errors, go fetch. There are different types of alerts that fit different needs. Let's talk about the main ones. There are immediate alerts. So I want to be notified immediately when a certain event happens. Save those to really critical things. So we spoke about fatal errors. So define an immediate alert on a log saying cluster, sent the bulk to Kafka and got a timeout. That'll be like, okay, something serious happened, or someone needs to look at it right now if I can't lose any record. So immediately when you have that log, send me a notification. There are what's called more than alerts. So if something happens more than a certain amount of times in a certain time frame, I want to receive an alert. And then you need to actually do some investigation before you define that type of alert. You need to look at the baseline, understand how many times you expect an error or an action to happen, look on a wider trend, try to identify that trend, and then look for outliers and try to catch those. So it's a process of trial and error to define the right alert. The worst thing to do is define alerts that are too sensitive. They create a lot of noise. They exhaust your organization. And at the end, they get ignored. Another type of alert that I really like, and I think is the most proactive alert, is what we call less than alerts. So I'm not alerting on the existence of logs. I'm actually alerting on the absence of logs. And that can be proactive in level of hours and days. For instance, if I have a table cleanup running every day, I probably want to define an alert that says there's a log saying table cleanup completed. It should probably be an info log, you probably remember. Let me know if that log doesn't happen every 24 hours. And then, when table cleanup doesn't happen, nothing happens in essence. No one notices. Crisis is going to come a week from now when things explode, and then you are in a crisis that is going to be very hard to resolve. But if on the first day you get an alert saying your table cleanup didn't happen, you can actually, it's not just proactive in a level of solving it before it happens. You can actually put a task in Jira to solve it the next day. So that's a great and very proactive alert that not enough customers use. And once you understand that you need the log alerts and you properly define them, and you know the different types that you need, now you want to create the right organizational structure to send those alerts. And just like alerts have to be very precise and very pinpointed, so as their channels, so as their recipients. So you want to have specific email groups, specific Slack channels, and a very clear policy for PagerDuty that we'll discuss very soon. And for instance, you want to have a Slack channel called critical errors in the US region in the purchase area of your in the purchase services. So now, whenever an alert gets there, even before I open it up, I already understand what happens. And just by looking at the Slack feed, I see what's lit and what's happening right now and which areas, which geographies, which services are getting alerts. And then when I open up that alert and it's properly defined on a very specific criteria, and it's not spamming because I defined the right type of alert, and that log has all the metadata that I need and the matrix that I need, now I can really act. I know what's happening. I can notify the right people, and I can solve the problem faster. And that takes us to the last part. That is what we call to push or not to push. And here we have this very clear understanding. You just need to imagine every time you define an alert, you need to imagine yourself getting that alert at 3 a.m. in the middle of the night, okay? So you get that alert, it's 3 a.m., you woke up. You open your phone, you look at PagerDuty, it's obviously ringing, and you see the alert. What do you do now? If you get mad, slam your phone, go back to sleep, just delete that alert. You don't need that alert at all. No one cares about it. Create a dashboard, create a report, create an API call that brings you a summary every day. You don't need that as an alert. If you saw that alert and you said, oh, that's really interesting, I gotta look into that tomorrow, then don't push it to PagerDuty. Just define that alert and have a daily scan of your dashboard to look at alerts that triggered, and that way go through those events and investigate and see what needs to be escalated. Only if your action was you get that alert in Pager, you wake up, you wash your face, you open your computer. Only then you push that alert so other people wake up now. So that's a very clear way of thinking here that will allow you to really define the right alerts, don't make them spammy, and make people take your alerts seriously. A little about how we use logs to enhance CI/CD processes. So in this case, I'm just taking a classic CI/CD tool, Jenkins. We have the build logs and we have the system logs. Build logs are pretty spammy, so you'd probably want to use only error logs from your builds. And you also want to collect your stats. So there are a few areas that you want to cover here. And at the end, you can generate nice alerts and visualizations, like in this case, where you can give histograms of how much time it takes us to do builds and the total time per date. Let's see days in which I have outliers and builds took longer. Build time versus the amount of builds. So let's see if I have some sort of issue with scaling of my CI/CD pipeline, that when I do a lot of builds, it gets stuck and takes way more time than I need it to. Pipeline by name and its timing. Let's see the worst and slowest pipelines. And stages. Let's see what stages in my pipeline take the longest. And top branches. Let's look at the hot branches, just understand what's getting the most changes and where I should put my focus in. Success rates of tests and slowest tests. This is important. There are a lot of very slow tests that slow down my CI/CD. And again, many times I want to deploy really fast if I want to fix a critical issue. So understanding those slow tests, utilizing them, or understanding if they're not important and removing them can really improve your CI/CD and reduce a lot of frustration when people go to production. When you combine that with system logs, specifically if you have more than one Jenkins server and you want to correlate and get a good understanding, this really helps you enhance your CI/CD and get the buy-in of most of your company, even if your company is not a big fan of that new process that you've entered, even if the R&D are not big fans of that, once they see that you optimize and you keep improving that process, you get their buy-in, and that's really important for your organization. So it's very easy to collect these logs. There are a bunch of ways. You can just read them using Fluentd or Logstash. Us in Coralogix, we created the plugin for Jenkins that you just install, and you get all the logs, all the metrics, and also version tags that help you benchmark versions, which is my next topic. So in Coralogix, we're not a huge development team, but it's pretty big. It's the biggest team in the company. And we release a lot of versions, at least 10 versions every day. And what we found out is that it's really critical to benchmark the quality of a version that you bring to production as fast as you can to identify problems or bottlenecks. So in Coralogix, what we do, we look for a few specific things in our logs and matrix every time we deploy to production. We look for newly introduced errors, which is really important. So you deployed a version, you want to see whether new errors were created in that version. We look for errors that always existed but suddenly happened more than the usual. We look for the general error ratio in that component. So if that component usually had 100 errors out of 1,000 logs, that means 10% of errors. I expect to see at least that after the deployment or lower. But if suddenly I have 15%, now let's drill into new errors or those errors that happen more than the usual and have a look at what broke. Another thing that we want to add are custom visualizations that helps us, for instance, monitor new features that we bring to production. So I want to monitor the usage of a new feature, errors in a new feature, so I just visualize them and track them across different versions, and also bug fixes. So if the bug was fixed around a certain exception, I can create a widget for that exception. And then after I deploy, I expect that widget to be flat because that exception shouldn't happen anymore. So if it happens, it's a very easy I have a very clear understanding that the version didn't fix it. I see the errors, I see the logs, I just send that link and reopen that bug. The way we handle issues after we identify them so fast using the version benchmarks is we take a time frame of 2 or 3 minutes to collect all the data that we can from production, whether it's logs, matrix, reproduction, console, anything that we can, and then immediately in parallel notify customer success and support. So in case anyone complains, we already have an answer with a clear explanation of the version that broke that, and then revert and take the data that we've collected to investigate offline. What's mostly important is the feedback loop. So after we benchmarked the version, we saw a problem that we did not identify in staging. We look at what broke, we look at the new scenarios that broke this new version in production, and we add these tests to staging. And that goes back to my previous slide to improve the CI/CD process itself, because now I understand that the benchmark helped me focus on a problem and solve it fast or revert fast. Now I want to improve my staging and my test projects so that this doesn't happen anymore when I deploy to production. So that's the version benchmark feedback loop. A little about logs to matrix and why is it the solution for many problems that we have with time series databases. So time series databases are great for the standard use case of monitoring infrastructure. CPU, memory, thread count, performance, response times, that's great. But what happens when I want to actually monitor my business logic? So if we take the Coralogix case, I want to monitor the time it takes us to process a single log. So the log process time, that's great. That's one metric. But what happens now is that I want to monitor it per customer. That's already over 1,000 metrics. And I want to really pinpoint to per customer, per source, because maybe a certain type of data, a certain type of integration causes slow processing time. So now it's already tens of thousands of different metrics, and many infrastructure monitoring tools, many time series DBs limit us there. to a certain amount of custom matrix per server and so on. Logs are a great solution to that because JSON data is already labeled data. So if I have a key giving me the processing time per log now in my data, I can just break it down, group by customer name, group by source type. And then I have this great tagged matrix data at a very low cost without any limitations. And I can just add fields in my log without going back to my code and implementing hooks to generate those matrix, and constantly improve my business logic understanding and my custom data understanding. So the only problem with that is cost. And this is something that we solve in Coralogix with a few features, but this is not the time to talk about them right now. A new approach for logging in Coralogix. I want to show you guys a really quick overview of what we're doing here in Coralogix. So this is the CoreLogics Dashboard. I'm skipping the intros. I want to show you guys a really quick investigation that I can do with Coralogix. So if I go to the log screen, let's say I have this crisis happening right now in production, and I want to investigate. So I'm typing in the word error. I'm looking for errors. I have 1,000 errors just in the past 15 minutes. Let's take a longer period of time. Let's take like 2 hours. It's already thousands of logs containing the word error. So log aggregation comes to our help. It happens automatically to each and every log because we figured that one of the biggest problems is the amount of logs that people need to read. So I just click log aggregation, and I'm going from 4,000 to 29 different errors. I see both structured and unstructured data here. It's very easy to visualize anything. So I see user ID, for instance. Even if it's unstructured, I just click and visualize it. And I can also visualize the JSON data. So I see different IPs. I just click the IP and get them. Now I identify that these two IPs are problematic. If an error happened hundreds of times, I can just click the occurrences in Coralogix and not only see that it happened a lot, but also see its behavior and its normal behavior. So now I see whether this error is happening more than I expect, and I can pin this to my dashboard real quick and monitor this as I investigate this problem. I can also drill down into a specific error just by clicking the magnifying glass right here and look at all the different errors coming from that line of error, regardless of their variables, and then zoom in specific areas that I care about. And once I find that one log that I want to investigate, query around it to get a better context. And then once I'm set and I understand my problem, it's very easy to just copy that, run that simple query right here, and define an alert straight from here. And then alerts can have, like I mentioned, immediate alerts, more than or less than alerts. And Coralogix helps me verify those alerts to understand whether they're going to be spammy, like this one, or I should improve my threshold and say only if it's more than 100, I can group that by something or not. But now I generated an alert that doesn't do anything. So I need to lower the threshold maybe, but Coralogix helps me with the more than usual and less than usual options. So now basically we define the alert, we define the parameters, and Coralogix builds a model that gives me a dynamic threshold. It learns and updates that threshold for me. So that way we can really easily narrow down on an issue and then create a dynamic smart alerts. For things that we're not aware of and not investigating, Coralogix is automatically identifying anomalies, either flow anomalies, where we understand sequences of logs. So 2 logs that should arrive together, suddenly the last log did not arrive at the ratio that we expected to. So instead of almost 50-50, the flow started 72 times and only ended 16. And then we point out suspected errors that happen more than the usual for this time of the day in that component, top errors and newly introduced errors, which is the most important thing here, an error that never happened before that minute and happened during the flow breakage. Volume anomalies track down the error ratios across all my components and lets me know whenever there's a spike of errors or a spike of bad API responses. So in this case, this component had 1.5 more errors than the usual. We can actually see that very clearly here in the graph. And then Coralogix also calculates the suspected errors during that time frame, top errors, and again, newly introduced errors. So basically, I rapidly investigate and define smart machine learning-led alerts. And even if I don't, Coralogix helps out by identifying issues for me and pinpointing their reasons. Now, you probably noticed this tag. This comes from our CI/CD integration. So not only our integration with GitLab, CircleCI, Jenkins, Bitbucket, and more generates the build logs and statistics, we also generate a tag every time we deploy. But besides seeing that tag, I can actually go, whenever I deploy a new version, click a tag very simply, and get a full benchmark of that version. So ever since I deployed 6 hours ago, in that component, no alerts or anomalies there in this service. High severity ratio rose a little. Here are the top errors in this version, suspected errors that happened more after my upgrade, and newly introduced logs in the version. And then I can say, just show me newly introduced errors and critical logs, and really quickly get that benchmark of new errors, suspected errors, error ratio, things that I've broken this version, and my own custom widgets to track down closed bugs or new features, and so on and so forth. Besides the whole Coralogix experience, we have a built-in Kibana latest version and an integration to Grafana, so you can visualize your logs and matrix really easily. And our log to matrix feature allows you to convert logs to matrix and store them for a long term, so you can use logs to solve your custom matrix problem. I'll stop sharing now. We have exactly 10 minutes, so we can I can take questions. So let me go to the Q&A section. I see a few. How can we get the slides? We'll definitely share them. So Larry Mahoney is asking how can we get the slides? We'll definitely share them right after the session. The Do It team will send it to anyone participating. I see a question here. If we have, so the question is, do you have a Kubernetes integration? That's a great question, because a lot of times, a lot of companies are now switching to Kubernetes, and logging Kubernetes is getting more and more complex. So yeah, we have built-in integrations for Kubernetes. Basically a daemon set that is really quickly installed. It can use either, you can choose between FileBeat, FluentD, or FluentBeat for your collectors, and it sends data directly to Coralogix, enriched from the Kubernetes API with all the Kubernetes metadata, like cluster name and pod ID and container ID and so on and so forth. A quick integration that's based on open source and really easy to set up. Cosmin Nicola asking, can you detail what exactly are you using ML for? So basically, log aggregation, the clustering algorithm that I've shown, flow anomalies, understanding relationships between logs, like sequences of different entries, volume anomalies that identify different trends based on seasonality, and of course, dynamic alerts that build a machine learning model on logs, and also the normal behavior that I've shown that we identify for each and every template that we create with log aggregation. Aviv Gold is asking, should I use TCP or UDP? What are the use cases? If you're talking about log shipping, then we usually, it's kind of different. We support both. For data that you want to have all the records, you should probably use TCP, and this is our default most times. If you are a company that generates a lot of high volume, low value data, and you want to have more statistics view on it, you can use UDP. It's less heavy, and it'll only lose about 0.5% of your data. If that's the case, by the way, it also applies sampling, which is also something that we support. And don't ship all that data, because it can get costly. So you want to do sampling of like 1 to 10 based on specific components and specific environments, and that way create visualizations and alerts based on your knowledge of what you're sampling. How do you add tags? Great. So we can add tags using our Jenkins plugin, our integration with CircleCI, with GitLab, TFS Online, Bitbucket, but also we support a simple curl request. So you can send a curl to Coralogix with your private key, the name of the tag, the application and components that you've upgraded, and the time frame of the upgrade. Is it possible to integrate other data sources in this dashboard via API? Yes, that's a great question. So there are APIs in Coralogix, both to pull data from Coralogix and send webhooks outside from Coralogix to other sources, and also to define alerts and parsing rules via API. And also, Coralogix integrates with your Grafana. So you can actually use Coralogix as a data source for your current Grafana and display multiple data types together with your matrix and logs generated in Coralogix. Do you have some sort of archiving solution? How much does it cost? And is it possible to restore? Oh, good question. So Coralogix has a built-in archive to S3. You just define your bucket, and Coralogix stores all the data in real time to that bucket per day and hour in CSV format. It's free of charge, and it's your own bucket. And you can restore data from that bucket using our reindex feature. So it's very easy to pick a time frame and rehydrate data back from S3 if you have some kind of compliance issue or something that you want to investigate in the past. Avnel Soek is asking, do you think there can be too much logs, or do you seen something have you seen companies doing logging that you consider as an anti-pattern? Definitely. So there are many companies that we see that the size of the company does not fit the amount of logs that they print. So I say one little thing that can be very, very useful. Instead of sending every single record, there are many mechanisms and also plugins to common collectors that allow you to send aggregations. So instead of sending one message in queue, one message in queue, one message in queue, just send one message every 5 minutes with the status of messages in queue. Another anti-pattern that we've seen is not using standard loggers, printing the console without escaping \n, and then most of the standard log agents break that down into different lines, and then you need to define multiple multi-line patterns. So that's also an anti-pattern that I've seen, and definitely things that I mentioned during the presentation: bad definition of severities and very general alerts. What else we got here? Richard Colasso is asking, how long to train AI models? Yeah, that's a great question. So Coralogix learns the templates, what you've seen in log aggregation, within 24 hours. And then 3 days later, we know the normal behavior of every pattern. And then the next day, we learn connections between different patterns, which is the flow anomalies. And then within a week, we learn the daily behavior of the data per week for the volume anomalies that identify error spikes or bad API response spikes. The models are learned every day throughout history, and we save statistics. So if your system evolves or your scale changes, we learn as we grow with you. And dynamic alerts build the model on demand and then learn it from then onwards. Larry Mahoney, what is your use of elk stack in Coralogix? Yeah, so besides everything that I showed you, Coralogix uses elk or Open Distro, by the way, one of the partners for AWS in Open Distro, to store your logs. So you can query them using the elk syntax, or define alerts using the elk syntax, or use Kibana, latest version, or Grafana integrations. So we use elk stack for that, and also obviously Logstash for your integration. Larry Mahoney's asking, what is your pricing model? Our pricing model is based on volume and retention periods. And we have quota optimizers, and we have lock rules to allow you to reduce the logs that you don't want to pay for based on specific services and severities, or based on regular expressions. So you can basically drop whatever you don't need. And our log to matrix allow you to store long-term statistics without paying for that, because we store them on a separate long-term index that allows you to visualize in Kibana or Grafana without having to store all that data. So we typically see companies reducing about 30 to 40% of their logging costs using Coralogix. Can you help me reduce my log expenses? I just answered, I think. Do you have support for SAML? Yes, CoreLogics support the SAML protocol entirely. We integrate with Okta, OneLogin, Active Directory, Google Login, or anything else. And we also support RBAC, and you can also manage multiple teams with different permissions and different indexes and limitations. In which scenario you wouldn't recommend this product? I think companies that are heavily on-prem, can connect to cloud, can send data, like banks or governments, even though we have compliances like SOC 2 Type 2, HIPAA compliance, PCI, FCA, GDPR. For some companies, they need to do a really thorough understanding how their data looks like and whether it contains data that they cannot send out. And if that's the case, then they probably need to consider an on-prem solution, which is something that we don't offer. Does it have predictive ability? Yes, definitely. So I think both the volume anomalies and flow anomalies provide very good predictive capabilities because they identify broken flows way before they reflect in errors or bad matrix or APM alerts. How much time did it take log aggregation to detect new logs? Log aggregation starts within 24 hours, and from then it's real-time streaming and clustering of the data. Yeah, we've answered everything. That's great. Mark, can you locate IP addresses? Yes, Coralogix can enrich your IPs, both with geography and also with whether they're suspected or not, if you need it for security reasons. So we have an enrichment pipeline that takes an IP, tells you if it's suspected, gives you its geography so you can put it on a map in Kibana or Grafana. I'm using ELK today, how easy it is to migrate. It's fairly easy because if you take into account that L in ELK stands for Logstash, it's just pointing out the logs to CoreLogics. And the onboarding is pretty easy because we use the exact same syntax for querying and alerts. And you can also start by using Kibana that you're used to, and then gradually moving into CoreLogics and get all the advanced capabilities that I described. And I never said why are logs called logs. So I'll really quickly say that. As you probably know, speed of boats and ships is measured in knots. The reason that it's measured in knots is that in ancient times, or a few hundred years ago, what they used to do is to tie a log with a rope and then throw that log in the water. And that log had a knot every few meters. And then you just wait for a few seconds and you measure how many knots have you passed through that time frame. And now you know how much time has passed and how much distance you went through. And you log that, you put that in a note. And then when you're in the middle of the ocean, the only thing that you know is the direction that you sail to and the speed and the time. So you have that notebook where you're saying this speed to that direction for 2 hours, and then this speed to that direction. And that log note, that log book, is basically your way of understanding where you are in the middle of the ocean. And that's the first log. So that's the log file that you're using today to understand what happened in production. I hope that was a useful session to everyone. If there aren't any questions, then I think we're good to go. Oh yeah, I see someone asked the last question. We have Akamai CDN. We're struggling with identifying patterns of unknown bot traffic. Yes, CoreLogics has a built-in integration to Cloud Monitor in Akamai that a lot of customers really like. It's a couple of lines to enter your Akamai logs to CoreLogics. And then we help you with a bunch of very nice dashboards to identify bots and attacks, and we enrich your IPs with suspected activities. And you can use more than usual alerts grouped by fields to identify, for instance, specific user agents or specific users accessing a specific endpoint more than the usual, or trying to tap into it, or getting to, let's say, your off path. So there are a bunch of ways to do that, or using ratio alerts that we offer to identify the ratio between, let's say, 401s to 200s, and let's see if we have more unauthorized accesses than the usual for a suspected IP, from a geography that shouldn't access my website, and so on and so forth. So the answer is definitely yes. And also Akamai generates a lot of data. So our drop filters can really make it cost efficient. So you can quickly integrate, not pay too much, and get a lot of very good capabilities around your Akamai logs.
Thank you again, Ariel, for the presentation, especially the origin of the word logs. I thought that was fascinating, and I'd never heard that before. So thank you so much. Thanks everyone who's joined. I know we're past time, so Maya, I think we can finish up the recording, and thanks again for everyone's participation.